Hello students, today our topic of discussion is conservative vector fields. A vector field V is said to be a conservative vector field if the line integral of this vector field V along any closed curve C vanishes. This means if this line integral along any closed curve C is equal to 0, then we say that this vector field V is a conservative vector field. Let we have a vector field V equal to xi cap plus y j cap, and say this is x-axis, this is your y-axis, this is origin, and we are considering a rectangle in the first quadrant. Say this point is P, this is Q, this is R, and this is S. Assume that this point is x1, this point is x2, this point is y1, and this point is y2. This means the point P is x1, y1, point Q is x2, y1, point R is x2, y2, and point S is x1, y2. Now, if we have to check that whether this vector field V is a conservative field, what should we do? We first of all calculate the line integral of vector V along this closed curve, which is rectangle in our case. So this line integral along PQRS. If this integral vanishes, means if this integral is equal to 0, then we say that the given vector field V is a conservative vector field. So let us try to evaluate this line integral. Now, this line integral may be written as the sum of 4 line integrals. This means V dot dr along PQ plus V dot dr along QR, then V dot dr along RS, and then V dot dr along SP. Now let us try to evaluate these 4 integrals one by one. After finding their values, we will add them to evaluate or to find the value of this line integral. So first of all, let us try to evaluate the first integral, which is line integral of vector V along PQ. So in this case, this may be written as the integral from P to Q, integral from P to Q, of vector v, which is xi cap plus y j cap dot dr. Dr means here we are in xy plane, so dr will be dxi cap plus dy j cap, and this is the dot product. So this may be written as integral x dx plus y dy, and here the point P is x1 y1, this is your x1 y1, and point Q is x2 y1. Now along this line PQ, we know that there is a variation in the value of x, but there is no variation in the value of y. This means y is constant at each and every point on this line PQ. This means dy will be 0. So here this dy will be 0 and we are left with integral x dx. And this x varies from x1 to x2, and this integral when evaluated comes to be x2 square minus x1 square upon 2. Now this is the first integral, this is the value of the first integral. So write down here the first integral as integral of v dot dr along this PQ equal to x2 square minus x1 square by 2. This is the value of the first integral. Now let us try to evaluate the second integral. Second integral means the integral along QR. So here the integral is from Q to R, and the point Q is x2 y1, and the point R is x2 y2. And along this line there is no change in the value of x. This means dx will be 0. So this dx will be 0 and we are left with y dy, and here the variation in y is from y1 to y2. So the integral will be integral y dy from y1 to y2, and it will be equal to y2 square minus y1 square upon 2. Now we write here the second integral, that is integral along QR of vector v. So it is y2 square minus y1 square by 2. Now we are considering the third integral, which is line integral of vector v along RS. So the point will be from R, limit of integration will be from R to S, and here the point R is x2 y2 and S is x1 y2. Now along this line there is no change in the value of y, so y is constant along this line, so dy will be 0. So here dy will be 0 and we will have only x dx, and the limit is from x2 to x1. So here this will be equal to x1 square minus x2 square by 2. So write down here the third integral, which is the line integral of vector v along Rs, and this is equal to x1 square minus x2 square by 2. And now we are going to evaluate the fourth and the last integral, which is along Sp, means the limit of integration is from the point S to point P. Now what is point S? Point S is x1 y2. So here it is x1 y2. And what is point P? Point P is x1 y1. So along this line it is clear that the value of x is not changing at each and every point on this line. This means dx will be constant, dx will be 0 along this line. So dx will be 0 means here we will have dy, y dy. Here we will have y dy, and the limit of integration will be from y2 to y1. So we will have y1 square minus y2 square upon 2. So this is the value of our fourth integral, which is integral over Sp. So integral over Sp will be equal to y1 square minus y2 square divided by 2. Now we may evaluate using these four results. We may write the closed path integral of v dot dr along the closed curve PQRS. Here the closed curve in our case is a rectangle. So this will be equal to the sum of these four, means x2 square minus x1 square upon 2 plus y2 square minus y1 square upon 2 plus x1 square minus x2 square upon 2 plus y1 square minus y2 square upon 2. So if we add these four, what we get? x2 square minus x1 square plus y2 square minus y1 square plus x1 square minus x2 square plus y1 square minus y2 square. Now here this is x2 square with positive sign, here with negative sign. Here minus x1 square, here plus x1 square, plus y2 square minus y2 square, minus y1 square plus y1 square. So in the numerator we will have 0. So 0 upon 2 means 0. So what we are getting here is a 0 value for this line integral. This means vector v is a conservative force field, a conservative vector field. So we may say from this result that this implies that vector v is equal to xi cap plus yj cap is a conservative vector field. Now we are going to simplify the definition of the conservative vector field. For this, let us assume that we have 2 points in a space. This is point P and this is point Q. Now, if we connect, say this is point Q and this is point P. If we connect these two by this curve and say this is curve C1, say there is another curve which connects these 2 points and this curve which says C2. Say this curve is C2. Now let us assume that we have one more curve here which is C3, which also connects the points P and Q. Now if we assume this curve means curve C3 plus C2, this one, C3 plus C2 means this one. This is a closed curve, and if we integrate a vector field V, means if we find the line integral of a vector field V along this closed curve, means along C2 plus C3, C2 plus C3. It will vanish if vector V is a conservative field. So first of all, let us write here, let V is a conservative vector field. Then in this situation, this integral may be equal to 0, or this may be written as the sum of two line integrals, one along this curve and the other along this curve. This means line integral of vector V along C3 plus line integral of vector V along C2, and this will be equal to 0. Say this is your equation number 1. Now once again we are considering here the curves, but now we are considering the closed curve C3 plus C1, C3 plus C1. Here I am considering this closed curve. So in this closed curve also we will have the line integral of vector dr along this closed curve, means C3 plus C1. This will be 0, and this will give you the result that the line integral of vector V along C3 plus line integral of vector V along C1 will be equal to 0. Say this is your equation number 2. Now from equation number 1, or say equation number 2 minus equation number 1. So write down here from equation 2 minus 1, equation 2 minus equation 1. What we get here, equation 2 is this one, means line integral of vector V along C3 plus line integral of vector V along C1 minus line integral of this vector V along C3 plus line integral of vector V along C2. This is equal to 0. This means this may be written as line integral of vector v dot dr, line integral of vector v along C3 plus line integral of vector v along C1 minus line integral of vector v along C3 minus line integral of vector v along C2. This is equal to 0. So this term may be cancelled out, and finally what we are getting here is that line integral of vector v along curve C1 is equal to the line integral of vector v along curve C2, and this line integral of vector v along curve C1 is from point P to Q. So this may be written as line integral along curve C1 and is from P1 to P to Q. Line integral of vector v along curve C1 from point P to point Q is equal to line integral of vector v along curve C2 from P1 to Q, from P to Q. So this result may be written like this. And what is the physical meaning of this result? Here this may be written that if vector v is a conservative vector field, then line integral of vector v dot dr from point P to Q does not depend on the path. It depends only on the points P and Q. So this is the alternative definition of conservative field. Now let us try to simplify this result. If we consider vector v is equal to nabla phi means gradient of phi, then the line integral of vector v along any closed curve, say your curve is this one, this is a closed curve C, this will be equal to the line integral of nabla phi along this curve C. Now this may be written as this may be written as here we are calculating this line integral along this closed curve C. So I am putting here this circle. Now this may be written as I cap dou phi by dou x plus j cap dou phi by dou I plus k cap dou phi by dou z dot vector dr means dx I cap plus dy j cap plus dz k cap, and this may be written as dou phi by dou x into dx plus dou phi by dou I into dy plus dou phi by dou z into dz. Now from the theory of partial differentiation, we may write that this expression may be written as d phi. We have seen this thing in our first and second lecture on partial differentiation. So this may be written like this, and what is the value of this integral? This integral will be equal to 0. Now, how this is 0? We may see this thing very easily. Say our curve is this one. This is your curve C. Now let us take any 2 points on this curve. Say this point is P and this point is Q. So if we write this part of curve as C1 and this part of curve as C2, then what is C? C is the combination of these two, C1 plus C2. So this integral means this integral may be written as integral along, means this integral along curve C, closed curve C, may be written as integral along this curve C1 plus integral along this curve C2. And along this curve C1 we have the first limit, means the lower limit of integration is P and the upper limit of integration is Q. So this integral is from P to Q, and in the second integral, means the integral of d phi along this curve C2, the limit of integration will be from Q to P. So here this will be from Q to P. Now this will be equal to, the first integral will be equal to phi Q minus phi P, and the second integral will be equal to phi P minus phi Q. This means this will be equal to 0. This may be cancelled out by this one and this may be cancelled out by this one. So we have 0. That's why I have written this integral equal to 0. Now what we can conclude from all these calculations, we may conclude that when vector V is a conservative field, then we may assume that there exists a scalar point function phi such that vector v may be expressed as gradient of phi or nabla phi. This phi here, phi is known as potential of the corresponding vector field. Now, this is the third definition of conservative field, that when a vector field V is expressed in terms of nabla phi, then we say that this vector field V is a conservative field. Now, we will simplify this thing using curl operator. So, since for a conservative vector field V, we may write V is equal to nabla phi. This means if we take curl of this vector V, we will get curl of nabla phi, means curl grad phi. So this may be written as curl of I cap dou phi by dou x plus j cap dou phi by dou I plus k cap dou phi by dou z. But we know that curl of vector V is equal to I cap dou I cap dou Vz by dou I minus dou Vy by dou z plus j cap dou Vx by dou z minus dou Vz by dou x plus k cap dou Vy by dou x minus dou Vx by dou y. So here what is Vz? Vz is dou phi by dou z. So it will be equal to I cap, or write down here curl of vector V is equal to I cap dou by dou I of, what is Vz? It is dou phi by dou z minus dou by dou z of Vy. What is Vy? It is dou phi by dou y plus j cap dou by dou z of Vx. Vx means dou phi by dou x, then minus dou by dou x of Vz. Vz means dou phi by dou z plus k cap dou by dou x of Vy means dou phi by dou I minus dou by dou I of Vx means dou phi by dou x. This may be written as I cap dou 2 phi by dou I dou z minus dou 2 phi by dou z dou I plus j cap dou 2 phi by dou z dou x minus dou 2 phi by dou x dou z plus k cap dou 2 phi by dou x dou y minus dou 2 phi by dou y dou x. Now we know from the Young's theorem that this expression, or say this differential, is equal to, this differential coefficient is equal to this one. Means these two partial derivatives are equal, here also and here also. This means it is simply zero vector, a vector having all components equal to 0. So curl of vector V is equal to 0. So here we are getting one more alternative definition of a conservative field, that when vector field V is a conservative field, then its curl, means curl of vector V, will be equal to a zero vector. Now suppose we have a question that check whether, or say, can we say that vector V is equal to x I cap plus y j cap is a conservative vector field. So here we have seen this question at the beginning of this lecture, and the method was the method of line integral, which was from the basic definition of the conservative field. Now this problem, we are going to solve this problem here by using this definition, means the fourth alternative definition of this conservative field. So we are going to calculate curl of vector V. Now what is V? Here V is x I cap plus y j cap. So it may be written as x I cap plus y j cap plus 0 k cap, or we can say that Vx is x, Vy is y, and Vz is 0, means the components of the vector along x axis, y axis and z axis are x, y and 0 respectively. Now let us try to evaluate curl of vector V. So from the definition of curl of vector V, it is I cap dou Vz by dou I minus dou Vy by dou z plus j cap dou Vx by dou z minus dou Vz by dou x plus k cap dou Vy by dou x minus dou Vx by dou y. So here I cap, what is Vz? Vz is 0. So dou into 0 by dou I minus dou Vy is y. So dou I by dou z plus j cap dou Vx is x. So dou x by dou z minus dou Vz is 0 by dou x plus k cap dou Vy is y. So here dou y by dou x minus dou Vx is x by dou y. This means here we are getting I cap into 0 plus j cap into 0 plus k cap into 0, or say it is a 0 vector. This means curl of vector V is a 0 vector, or we can say that the given vector V equal to x I cap plus y j cap is a conservative vector field. So this is a very interesting and useful concept, and such type of problems are asked in several competitive exams like CSIR NET, like IIT JAM, TIFR, JEST, etc. So this is very interesting and useful concept for the students of physics. So you should learn this thing. Thank you.